Good evening, my little chemistry fans. Anyway, here at Coach Scott's Chemistry, I thought it would be a really good idea if I was to work Worksheet S, especially after the test today for a lot of you guys. So anyway, let's think about this real quick, okay? This first question is asking what? It's asking what? It is asking whether an element or whether something is an element, a compound, or a mixture. Now, the only pure substances we're going to deal with are either elements or compounds. Elements are found on the periodic table, right? Compounds are a mixture of elements from the periodic. Now, mixture is not a good term. Compounds are a combination, there you go, of elements found on the periodic table. Mixtures are a conglomeration of either elements or compounds, but more than one or two of the same thing. All right. Now, if we have a mixture, it's either homogeneous, which means it's all the same throughout, or it's heterogeneous, which means it can be different from a sample on the top or sample on the last. So let's look here. Helium. Helium is on the periodic table, so that has to be an element. I'll just put E for that. Nitrogen. It's on the periodic table. Think carbon, nitrogen, oxygen, hydrogen. Definitely elements. Pure water. Keyword there is pure. Water is not on the periodic table. H2O, which is the formula for water, is, right? Dihydrogen monoxide. Another name for the molecule. So it's pure. So it's either got to be an element or a compound. It's pure. That means it has to be a compound. Pure, keyword there, pure table salt, also known as sodium chloride, NaCl. These are a combination of elements, right? They're a compound. It's a compound. It's pure. It says it's pure, so it's a compound. Flat, uncarbonated Coca-Cola. If you look at a can of Coca-Cola, if you look at a bottle of Coca-Cola, you'll see caramel, you'll see caffeine, you'll see all kinds of ingredients, right? Being uncarbonated means it's all the same throughout. If it was carbonated, you'd have a mixture of gases, and they might have more on the bottom than on top, so that would not be homogeneous, right? But it's flat. That means the top is the same as the bottom, so it is a mixture, and mixtures are either going to be homogeneous or heterogeneous. This is a homogeneous mixture. Air. Air has got nitrogen, it's got oxygen, it's got water vapor, it's got a little bit of everything, right? So it's a mixture, all right? Air is the same throughout. That's why we can breathe. So it's a mixture, and it is homogeneous. All right, a fruitcake. Think about a fruitcake, those nasty things you get at Christmas. It's got the little fake cherries and this, that, or the other. All right, it's a fruitcake. You may have a cherry on top, may have one in the middle, may not. All right, so it is a mixture of stuff, right? Like a chocolate chip cookie. Chocolate chip cookie is a mixture of different things, flour and baking soda, chocolate chips, nuts maybe. So you may have one or two nuts, you may have one or two chocolate chips per chocolate chip cookie. So that would also be a what? Homogeneous or heterogeneous? It is a heterogeneous mixture. Okay, so enough on those. Now, let's go over here. You got that? That's where we're going to classify stuff as either an element, a compound, or mixture. I think we got that for most of the part. Now, is it a chemical or physical change? A physical change is when something still stays the same. If it's a compound, it's still going to be that same compound. It might change its state, all right? It might go from a solid to liquid, or liquid to a gas, or what have you. Ice melting, all right? It's H2O before when it's ice, when it's a solid. It's also H2O after it melts, but it's liquid then. So this would be a physical change. Burning gasoline. When you burn gasoline, you go from a hydrocarbon, all right, ethanol or ethane and propane and all kinds of other little anes, okay, as a hydrocarbon. It's from crude oil. When you burn it, it's going to turn into carbon dioxide. It's going to turn into CO2. It's going to burn into water, all right, and some other nastiness. So this is going to be a chemical change. When perfume evaporates from an open bottle, you lift the top, and you're on the other side of the room, those vapors, all right, those little molecules of perfume are coming out. You're smelling them, right? They're being diffused through the air. So that is a physical change. It's not a chemical change. So guys, we should be able to get this pretty easy. Let's take a break from that, and I'll go ahead and publish this video, and then I'll do the rest of worksheet 1S. So you'll be ready for this test. All right, so guys, talk to you in a bit.